Well, is the Earth flat? Well, instead of having to download some picture from NASA and go to outer space, well, that's not really achievable for us regular people. So I've created an experiment that can be replicated by the average person with an internet connection and a computer or a phone. So, well, I'm not a scientist, so hold on 1 minute. All right. Well, now I'm qualified to make an experiment. Well, not all of us have college degrees and fancy letters after our name, but that doesn't mean that we're not capable of testing this kind of thing. So, what I've done is I've orchestrated an experiment where basically I've selected some cities in the northern hemisphere, near the equator, and in the southern hemisphere, and then went on Google Flights and calculated how long it would take to fly to each city. So depending on whether you think the Earth is flat or ball or whatever shape, go ahead and make your hypothesis, and then we'll go through the data, run the numbers, and then you'll get your result. You're either going to be right or you'll be wrong. So we'll go ahead and if you're going to think that the Earth is flat, the map that I got from the Flat Earth Society shows the North Pole being in the center, and then the South Pole, or Antarctica, is basically an ice wall that goes around the ocean, and that seems to be, from what I gathered, to be the most prominent map. So if that is true, the cities that are near the North Pole should take the least amount of time. The ones around the equator should take more time, and then the ones around the outside should take the most time to travel around. So let's go through the data, and bear with me. It's probably going to get a little boring, but I'll go through all the steps, and you will be able to verify and see if you're right or not. So let's get into it. Alright, so here we are in the computer. This map right here I downloaded from the Flat Earth Society website, and basically the description that it has on there says that the North Pole is the center, and the South Pole, or Antarctica, is basically an ice wall around the outside that contains the ocean from spilling out the outside. So this is the map that we're going to be using today for today's experiment. So the first one I'm going to go through is the flights that I selected for this green circle right here, which is kind of like the North Pole, or the innermost circle. So I have selected these cities: New York, Paris, Beijing, and Honolulu. I tried to pick cities that were pretty big, well known, and popular, so that there'd be a lot of competition for airline flights. So let's just go through it. New York to Paris, 7 hours and 11 minutes. 6 hours 55 minutes. Go with this one. Paris to Beijing, nonstop, 10 hours 5 minutes. Beijing to Honolulu, 13 hours 10 minutes. And Honolulu back to New York, 9 hours 30 minutes. So that's going to be from here to here to here to here and back to here. So let's go through the cities for the orange circle, which is close to the equator. I didn't want to use Hawaii again, so I just went from here, Singapore to LA. You guys, I more than encourage you to try this on your own. Try it to Hawaii. Go everywhere. Go ahead and replicate and add to this experiment as much as you like. For these cities, I selected Singapore, Dubai, Los Angeles, Miami, Madrid, Spain, and Dubai. So from Dubai to Singapore, let's go 7 hours 30 minutes for the first flight. Singapore to LA, 15 hours 45 minutes. LA to Miami, 5 hours 10 minutes. Miami to Madrid, looks like, what, 8 hours 35 minutes. And Madrid to Dubai, 7 hours 10 minutes. Okay, so for the last one, which is down here in the southern hemisphere, or near the closest I could get to Antarctica without, with staying with pretty major cities that would still have direct flights. So I chose Melbourne, Australia, Santiago, Chile, Sao Paulo, Brazil, Johannesburg, South Africa, Perth, Australia, and back to Melbourne. So let's go. These ones, they have a lot less competition just because not that many people fly there. So this could definitely be improved upon by you guys if you wanted to go ahead and map some of the other routes. The reason I chose these routes is because I didn't want to have a bunch of extra flights. The other ones had 4 and 5, so I tried to keep it with 5. So it wouldn't skew the results by having a bunch of takeoff and landings added to the flight times. So Melbourne to Santiago is 13 hours 15 minutes. Santiago to Sao Paulo, 3 hours 50 minutes. Sao Paulo to South Africa. This one, I'm going to go ahead and use the 8 hours and 25 minutes. You could do it with the 10 hours 20, but I've been choosing the shortest route on all of them, so I'm just going to continue with that. South Africa to Perth, Australia. We're going to go 9 hours non-stop here. And the final one, 3 hours and 30 minutes. So I have gone ahead and calculated that already. And total flight times for the green circle, 36 hours, 35 minutes. The orange circle, 44 hours, 28 minutes. And the purple one, 38 hours, 5 minutes. So looks like if the Earth was flat, these purple ones should be significantly longer flight time than any of the other two, but obviously that's not true. The purple one is close to the green one, meaning that this map would not be possible using flight times from the free market. I want to talk about kind of the scientific community in general and academia, is I feel like there's kind of like this elitism, kind of like oppression or whatever you want to call it, where kind of like if you don't understand something, nobody cares, and I think that's kind of a problem. We need to focus, more on explaining why things are the way they are, especially on more of an entry level. When people say, why is this, or we shouldn't just assume like we're kind of told, this is true and this is true and this is true, and then that kind of just goes and goes and goes, and then finally people come and are like, well, I don't think so, this other way, but like we've lost all that, all the steps of why this is true, and maybe we need to just take a step back and go over that again for some of the people who weren't around when we discovered it the first time. So that's kind of, what I try to do sometimes on stuff that I understand. So hopefully you guys enjoy these videos, and maybe I'll do some more in the future.